Hi, welcome to Prim's algorithm example to build minimum cost spanning tree. For Prim's algorithm, we will select always the minimum edge to form a single tree. We can select any vertex that should have path to all other vertices from the selected vertex through other vertices. Here we can select the minimum weight adjacent vertices from the selected vertex that is connected to that particular selected vertex, so that can be added into the minimum spanning tree. Then from that selected vertices, so suppose if you are having the 1 and 2 here, so if 1 and 2 is selected, from that any one of these vertices you can select minimum weight edge, next edge. For example, here it is having the 4, it is having the 5, it is having 2, so you have to select any one of the minimum edge in this given connected vertices in the MST. So now you can select them 2 that is already connected with the 1 or 2. So here 1 is having that 2, so then we can select that edge that is going to add in the already created MST. So already created MST is having this one. Now the 2 is going to be added with the 1 and 4. So now this is the new MST, updated MST. We have to repeat this until connect all the vertices in the given graph. So now we will see the example. The given graph is having 5 vertices and 7 edges. So the 5 vertices are passing the values to connect with each other. So this is the 0th vertex, first vertex, second, third, 4. Here also this is the 0th vertex, first vertex, second vertex, third, fourth. So now we are making the edge cast. So now 0 to 0 there is no path, so it is the 0. So 0 to 1, here it is 2, then 0 to 2 which is 0, so there is no path from the 0 to 2, so 0. 0 to 3 we are having the 6, this one. 0 to 4 we are not having any edge, so that is 0. Like that, when you are taking the vertex 4, from the 4 to 0 there is no vertex, no edge, so 0. From the 4 to 1, the 4 to 1 we are having the 5, so that is mentioned here. Then 4 to 2, this is 7 which is given here. 4 to 3 which is 9 given here. Then 4 to 4 there is no edge, so it is 0. So like that we are passing the values, then we are calling the Prim algorithm method to construct the minimum spanning tree. So Prim MST, which is taking the all vertices and edge values. Here we are creating the parent to all the vertices, so to store the constructed minimum spanning tree initially. And also we are creating one of the key, so key is the edge cost, and here we are making the MST set. MST set is used to store the visited edges, either that is visited or not visited. That means connected to minimum spanning tree or not connected. If it is connected it will be true, if it is not connected it will give you false, so boolean values. So initially the key values, all the key values are set as a infinity, then under which is set as a not connected with the minimum spanning tree. Then we are taking key of 0, that is the for 0th vertex. For 0th vertex we are assigning the key is 0. So for the 0th vertex key value is now, as of now, 0. Then parent of the 0 is unknown. Okay, parent of unknown 0 is unknown, because this is the value taking as a root in the MSTs. For example, this is the MS, I mean, a minimum spanning tree. We are going to select now with the first vertex 0, that edge value also 0. So now we are going to visit all the vertices. We are starting from 0. So key is now 0, that is given here. Then the MST set of the 0 is already set as a false for all the vertices 0, 1, 2, 3, 4, all are set as a false. So for 0 we already set as a false. We are calling the minimum key method. So minimum key we have to find out for the 0. Here boolean set is here we are passing as a false. Now we are setting the value minimum with infinity now, and minimum index is -1 as of now. For then for the first vertex to minimum first vertex to all the vertices we have to execute the for loop. If the MST set of the V is here, we are having the value false. Okay, so this is as of now MST set of 0th vertex we are passing here. Okay, we are passing here, that is the false here. Yes, it is false. False equal to false is true now, and key of 0 is now 0. This is set here. Okay, 0. Then already the minimum values here we have set as infinity. If 0 less than infinity, yes, this is also true, this is also true. So true and true, this is the true. Now we are setting the minimum value as key of V is here 0. So that 0 is assigned to minimum, and the minimum underscore index is V. So here vertex is 0. So 0 is assigned to minimum underscore index, then it is returning the 0 here. So now the U is the 0, source vertex is 0. Then we are setting that the minimum set of true. So source vertex is visited now. Now you look at this 0 is added into the minimum spanning tree. Now after adding that 0 into minimum spanning tree, now we are going to connect all the vertices which are available connected with the 0 as per given input. So now we are passing 0 to 4. Okay, this is the number of vertex is 5, so we will pass until 4. Now we are passing graph of the U is 0 here, this is the U, and V is also 0 now. U of 0 of 0 not equal to 0, but 0 of 0 key is 0 here. Now you look at that, key is 0, right? So now 0, if it is 0 then it is false, so the if loop will not execute. Then again go back. So in the for loop it will increment by 1 here. It is increment by 1, right? So now that it will come 1, V will become 1. So for U is 0, V is 1, not equal to 0. Yes, 0 to 1, 0 to 1 here, look at that, we are passing the value 2. So it is not equal to 0. Yes, it is true. And MST set of V, so here V is 1. Okay, this is now false. Okay, it is not visited, still not visited, it is false, because already look at that, here we set MST set of 1 is false. Okay, MST set of 1 is false. So based upon that, now we are checking false equal to false, so it is also true. And graph of U of V, is here the value 2. Okay, value 2. So this is the value 2. So graph of graph of U comma V is 2 less than key of V is already set here 0. Okay, key of V is here, it is set as 0 already. So now this is look at that, the no key of V is infinity as of now. You look at that, we have set the infinity value to all the values, all the vertices. So now key of V is here, this is now infinity. So 2 less than infinity, which is true. If it is true, now we are coming to U as a parent of V. So now V is here 1, right? So for 1 the U is 0. So for 1 0 is the parent. So now look at that, we are making the parent to the 1 is 0, right? Then key of V is graph of U comma V. What is the graph of U comma V? The edge value, graph of U comma V is 2. Okay, so the 2 is assigned to key of the vertex 1, key of vertex 1, right? So like that, again we have to increment the v value will be 2. So now again a graph of 0 comma 2, that edge value is 0 comma 2 is here, it is 0. You look at that graph of u comma v, right? 0 comma 2 is 0, it is false, then for loop will be incremented by 1. Now v equal to 3. So again here you will take that 0 comma 3. So 0 comma 3 not equal to 0, yes it is true, right? Then MST of 3 is false, yes already we have seen MST of 3 is false here. Then now graph of u comma v, what is u is 0, v is 3. So graph of u comma v, 3 is 6 less than that unknown value, right? So yes it is less than value, right? So now parent of u, so parent of v is here, the v is 3, then u is 0. So now we are assigning that for 3 0 is the parent, right? So now the value, edge value is updated. So like that we have to keep on do it. Then we have to find out the minimum spanning tree based upon all the vertices values. Then finally we will print that value here by calling the print, and here we are passing the parent value and the graph, passing the parent, because we are keep on updating the parent value for all the vertices. Then finally for all the vertices we will print the parent of given node, of given node. So finally we will get the values here for the 0 to 1, the minimum weight for 0 to 1 is minimum weight is 2, and 1 to 2 here 1 to 2 is the value 1 to 2 is 3, then 0 to 3, 0 to 3 is 6, and 1 to 4 is 5. So this is the minimum spanning tree among all number of possible spanning trees. Thanks for watching. And here you can calculate the total cost. So total cost will be 2 plus 6 plus 3 11 plus 5 16. So 16 is the total cost of the minimum spanning tree by using Prim's algorithm for given graph. Thanks for watching.